cyclin-dependent kinases, or CDKs for short, are crucial regulatory proteins in the cell cycle. When activated, these kinases transfer phosphate groups from ATP to serine and threonine side chains on target proteins. When inactive, the active site of CDKs is sterically occluded by a loop, often referred to as the T-loop. As their name suggests, cyclin-dependent kinases are activated by cyclins. Cyclin binding to CDK pulls the T-loop away from the active site and exposes the bound ATP, allowing it access to target proteins. Thus, a CDK can phosphorylate target proteins only when it is in a cyclin-CDK complex. A third protein, called a CDK activating kinase, is required for full activation of CDK. This kinase adds a phosphate group to a crucial threonine in the T-loop, thereby enabling CDK to bind to and phosphorylate its target proteins. Target peptides bind to the active site of the cyclin-CDK complex so that the target serine or threonine side chains are precisely positioned with respect to the gamma phosphate of the bound ATP. CDK inhibitor proteins, or CKIs, help regulate the rise and fall of cyclin-CDK activity. Some inhibitors, like the one shown here, bind directly at the kinase active site and block kinase activity by interfering with ATP binding. Other inhibitors bind near the active site and interfere with substrate binding.